All right, let's get started here. So, my name is Scott Champagne, and this is Linux Automation Unit 2. We are recording this for YouTube and also for the people that don't get to come to the live sessions that we normally run. So, let's get right into it. Our announcements for this week. Well, me and the wife were out of town, so I guess this doesn't apply now because I'm recording it after. But this is our second class meeting as far as that goes. If you want to get involved down in the Discord, you can. And that's free. You just have to go down there and get started. All right, so what do we do in this course? Well, last week we had to do some discussion posts, right? You got to do one post about the topic and then at least one response to somebody else, but you can sit there and talk to them as much as you want. The first question of the course is, what is automation? So we got into, this was last week, right? So this is a review. The first question was, what's automation? What does that mean to you? How does that kind of work? And then we started talking about triggers of automation and how we could trigger automation and those type of things, right? We had a worksheet last week and we had a lab. And the course objective was to kind of see what our automation tools were. Make sure we can get into a lab, make sure we can execute on those tools. Because then for the rest of the course, we're just going to be using those tools to do things as administrators and engineers and all these types of things that we want to learn automation for, right? All right, so that was last week. A little review about last week then is we talked about engineering. What is automation and what do triggers have to do with that? Talked about the types of triggers, the types of ways that triggers kind of look in a system. And then we talked about what tools we have for automation. You know, we got Bash, we've got Python, we've got Ansible, and then we've got everything else in the world. But those are the three that we're kind of focusing on for this course, right? And then we started talking about like framing things as an automation mindset. What do we do and where do we set up automations? What type of automations are we going to use as admins and engineers? And we're going to explore that kind of throughout the whole course, right? I mean, automations are kind of why we use computers in the first place, so it kind of fits in with everything else that we do. All right, so a little bit of the review. We talked last week about the scientific method. You just kind of have to know what this is. I mean, in any type of STEM or any of these types of fields that you might find yourself, you know, we do science in a certain way. And then engineering puts this practice into like a repeatable physical thing. In fact, a lot of times science is very abstract, and then engineers, we actually apply these things to repeatable practice. That's a thing that we do as engineers. I like to tell people all the time, we do a lot of engineers. We probably do more science than most people do because we're applying things that are scientific. In that we know that they work the way that they are supposed to. You know, we talk about signal engineering and things behave the way that we understand them, and they always behave that way. Therefore, we can send signals and we can receive signals and we can do all these things because we understand how it works, right? So scientific method, not going to dig too much into that as a review, but it is good to know. Engineering kind of looks like this. We have things that cycle, right? And we can build cycles because we understand that the inputs of one go into the output, or the input, and then the output of one goes into the next step, and then we can continue on through that way, right? All computer science is input, process, output at some point, right? We take some input, we process it, and we output it to wherever it's going to stay, right? And then is it staying up in RAM? Is it being committed down to memory and disk and all these type of things? Is it persistent or is it volatile and all these types of things, right? And from that, as kind of like stepping back out of computer science and just going to process engineering, we also have suppliers and customers to think about, because input, process, output is awesome, right? Like it's how we do computer science. But does the supplier understand the format with which they input to like a web form or an API call or something like that, right? Like, do they understand the way in which they hand in a token as a header? Right? Are they handing it in as a header or part of the JSON? Like, how are they doing that? And you know, what's the encryption scheme and all these things? So suppliers, and then also the customers, the people that are reading the data back out of a system, are they able to read things a certain way? So engineering deals with all this, right? Like, these are the things that we need to kind of know and understand. And I say this as a very important concept of engineering, even though it's an automation course, we're doing a lot of engineering. Any deviation from normal acceptable processes is the absolute enemy of engineering. For each one of these things, I would have like an upper control limit and a lower control limit, and as long as things are happening within there, I would be able to continue on with my cycle or my process or whatever I'm doing, okay? Then automation starts, it's an extension of the engineering cycle process, in my mind at least, right? Where triggers can cause events to occur or cycles can start without us manually doing it, right? I can have things happen because of an event or a trigger or a log or any type of thing that we want, right? And then I say it's important to accurately break down each step in a process to be able to properly implement automation. There's a guy, Edwards Deming, who used to say, he's very famously said, if you can't describe everything you do as a process, you don't know what you're doing. And I would agree with that. If you want to get into automation, you have to be able to have things work through to completion from a engineering standpoint. They need to be able to cycle completely. And this is the thing that I talk about here, where the actions have to get to the end unprompted, uncorrected, or realigned. I don't have to reset things. I don't have to stop things, start them again, that kind of stuff. That's something you have to work out as you're building your automations out, right? So we're going to be doing that kind of the whole time we're doing the course. All right, triggers. So common triggers for automation, like the things that can cause things to happen, are time. Time is a very common thing, right? And I gave one of my favorite starts to a poem there. If anybody knows where that's from, feel free to let me know. I grew up with that story. Chronological is every day, time, minute, right? Chron is great for waking up between the first and the fifth second of every minute and running something if it needs to. Epochs or spans are how many hours from the last run. So maybe at the completion of the last run that may have lasted however long it did, we start again, like this kind of stuff. And then there can be events. Events can trigger things, right? We have a lot of event-driven systems are probably one of the most common type of large distributed type systems that we have on planet Earth, because, well, all the big cloud vendors use them, but also it just works really well. Like, I can just have a whole bunch of systems back waiting, listening as consumers of some produced either. We could use Kafka. We can use Kafka's a very common one. We can use EventBridge inside of Amazon Web Services. I'm sure Google has some version of it, and Azure has some version of it. But it's something where it's almost like you're just throwing it in a trough, and whatever machine gets to it just starts to consume it and do work on it, right? This is what we do, right? And those can be events. I mean, we can have SIEM systems that are triggering security events, and then in Azure we could have like the custo query language where we're going and doing what we call runbooks or fixes, right, to fix security events in real time without people even intervening. And then you have to kind of think about it as we get into the course more. What do we want to kick off automatically? I've been telling people, like, we've been able to fail over and fail back within like large scale engineering systems for the entire time I've been doing this, almost 25 years. But do we always want to fail back? Just because a system came up doesn't mean it's been checked out and should be released back, because maybe it's going to fail again. Maybe it takes 45 minutes before the processor heats up because the fans are busted, but that system starts taking the load again, and it's running into what's eventually going to be, it's eventually going to hit a wall, right? Because it's not going to be able to work anymore. So events are great. Alerts are generated from thresholds, high water marks, or other monitoring of events, right? So events are happening. They are causing logs, and they are triggering other things to happen. But events are discrete things that happen within a system. That's very important. But alerts are when some threshold is met and we want to generate and send outside of a closed system. That's typically the way I think of it. Events happen within a system. Alerts are once we send outside the system. And I think I used this example last time, but this is a very common one for me. I think of alerts as kind of like if you're boiling water, if you guys have ever done tea or something on a kettle, and you boil water, and when it starts to get too much for the system, it starts alerting out. Like, hey, the 212 degrees that this thing had to reach might even be different under pressure. I don't know, but I actually know it is different under pressure, but I don't know how hot it is. But in open air, at sea level or whatever, it's like 212 degrees. It starts to alert outside of the system because the pressure's too high, right? And that's that little whistle you get on a tea kettle. That's a type of trigger to let you know the thing is done. All right, we have tools, Bash, Python, Ansible. We're going to touch them each week. In fact, this week we have labs that you're going to interact with the operating system on that. Okay. Again, this is all last week. And a lot of times when we frame and when we want to learn things, we think of the problem, right? It's like when I touch my arm here like this, it hurts. So the doctor says, don't touch your arm there. And you go, thanks, doc. And then you pay him a whole bunch of money, right? Well, the central problem of systems engineering is consistency, reliability or repeatability rather, of doing the same thing over and over again. If I produce 30 work items, 30 artifacts, are they all exactly the same thing? If I generate servers from a VMDK and ESXi, is it always the same exact server every time? Is it is always the same thing. And again, then there's this thing where they have to be exactly the same, but they have to be slightly different too, right? They have to have a new IP and a new host name or whatever, and then that probably has to be checked out and written into your IP address management solution. There's all these things that have to happen, and it has to be consistent. It can't just be Scott going and not following the procedure correctly and breaking something. That's bad. That's really just bad for your team. It looks bad. And then timeliness. It takes different people different time to start. Some people come in the morning and they get their work from their, you know, their change management or whatever their tool is that gives them work, and some people don't get to their server builds to the end of the day. And that's not acceptable for a team that expects a server build within 5 minutes. Which, by the way, is not unreasonable nowadays in most companies. You should be able to build servers pretty quick. So in a virtualized world, you should be able to stand up servers pretty quickly after the request. And if we build out our automation to do that for us, it can be, you know, very, very light to us as far as like the work of maintaining it and that kind of stuff. It can just happen. So the automation mindset, we try to do some DevOps type stuff where DevOps is trying to pull our hardware and our server provisioning up into the same software lifecycle methodology where everything produces an artifact, right? Everything is pushed up in and becomes part of code or a block, right? Like everything we do produces some artifact that can then be checksummed and turned into a, you know, thing that can be deployed somewhere else. Acceptance testing becomes part of the build. Every time we run and build things, we can have a test built in, and then we always peer review before we go into production, right? So dev can always be spinning, and we can be doing stuff and building and producing more artifacts. Every code commit can be tested. We can do all these things, right? Test in our branches before we push up to main or whatever, right? So DevOps methodology, very important. And then I tell you guys this, like, I don't know, like I never understand why certain things get looked down on. Like they're like, oh, that's not true engineering, or that's not a you know, whatever speed type query of whatever thing. Well, there's a certain value in being able to do quick and dirty one-off commands. Don't ever let anybody tell you like, hey, you shouldn't learn all of these different pieces, like, because you're going to get asked in a meeting. Sometime you're going to be like on your computer or something. Somebody's going to be like, hey, can you get this piece of information? And if you can pull that information quickly from a set of servers, people are going to almost, they already think Linux people are doing magic, right? I've been telling you guys this for a long time. People automatically think that we're in there casting spells, but the ability to pull information quickly from your system, and then if people are constantly doing that, maybe you build that into some type of automation where that's presented as an API that they can query, or that's presented as a report in the morning in Teams or Slack or whatever it is. That's one of my favorite things to do, is just present out, hey, here's the state of the system. Hey, all the system, like all, you know, all quiet on the Western Front. You know, you wake up in the morning, you do stand to in the military, make sure nobody's attacking, and then you can continue on with your day. And that's kind of, you know, nothing happened in the night. Everybody's here, nobody's wandered off, that kind of thing. And we can do that with our servers and our systems, right? So quick and dirty one-off commands start to become the basis for how we go and do our automations for checking things and reporting, which we are going to get into later in the course. This week, so that was last week. That was all review. This week is one post and one response on, we're going to have this automation cycle that I present in this unit. It's in the discussion in the worksheet as well. And you're going to answer some questions about it. Answer the questions. This has been up for a week and a half now, by the way, just so you guys know. But it's in the Discord. It's free. You can go in there and participate. And then the other one is, what is the Pareto rule? And what is meant by the engineering concept of the 80-20 rule, which is often called the Pareto rule or the Pareto principle. You'll find it said all kinds of different ways. Then the worksheet has take notes and review materials for this week. That's what we do. And then the lab is going to be interact with the OS from our automation tools. And that lab is going to get published. We have a site here that's being, you know, the guys are constantly working on it. And this, I will link it to you guys, but it's also the reason most people would participate with the course here. And then we are in Unit 2, which is interacting with the OS. And then eventually this will take you to all the different sections. So the guys are working on that. All right. So the course objective for this week is still that first one, right? And it's deploy various automation tools for engineering and operations activities. And this week specifically, we're going to be interacting with the operating system, making sure that we can do things and you know, participate with the system in a certain way. Okay. So here's our overview. We're going to talk about the automation cycle and how does that automation cycle function in an enterprise, right? We want to do stuff for some company. We want to maybe even deploy our own systems and run our own company, or maybe we want to go do contract work and we're going to get dropped in and have to help other people automate things. So what does an automation cycle look like, and where do we deploy it and how? And then I say, how do we build for all the eventualities of differences in so many systems? You know, you have 1,000 servers out there and you weren't responsible for building them, and you don't know even where the process is for how they got built in some cases. You can guarantee those are all 1,000 different servers. So how do we figure out what's going on with them? How do we kind of rein them back in and have control of them again? That's a good question, right? So then system checking, what do we check in a system? And what do we need to know to differentiate systems? To put systems in different places and different buckets, and in the Ansible world, what we call inventories and host groups, right? So how do we do that, right? All right, so here's the automation cycle. Generally speaking, as I like to look at it, you've got some type of trigger that kicks it off. It can be time or an event or an alert. Then we'll have typically some type of input validations. If there's inputs being read, like an event file or something like that, those will typically get validated as the system or whatever the tool is starts. You know, if you have syntax errors, if it starts to run and then those variables aren't there where it expects them to be, you'll have runtime errors. Those are kind of input validations that happen at the beginning, although you can have your own. And then I like to do system checking, right? Check what are the servers running as their operating systems. Put them in different buckets and kind of I always use this example of a Plinko machine where I don't know all the servers that I'm going to get through some type of automation or running of, especially in an enterprise. You don't know what's going to come out of that gate. So you have to be prepared to deal with those servers, right? So we're going to talk about that. Separate those systems out based on variables and into different categories, and then you can do work on them as appropriate, right? Then after we've done that, we execute whatever our primary function is for whatever automation we're doing. Maybe we're patching, maybe we are deploying some new application. You know, maybe we had a set of servers already and then a dev team needs a new version of, I don't know, all kinds of tools they might need to deploy. They might need to update their Tomcat on top of our servers, and we might do that and then overlay a new version of their app or something, so we might be pulling it out of Git. Our automations may have to touch all of these things, right? And then when we're done, system validation, right? Like, is the system back in a state like we originally found it and back working in whatever way we expect it to? In fact, when I do patching here, me and some of the other guys in Discord have worked together over the years. Sometimes system checking, when we get to the end after our system validation or checkout, there's also an app checkout. Some people might group it together. It's really one of these, you know, how do you want your steps to be? And then we report out when we're done. We send to an email, Slack, Discord, logs, maybe another event trigger to let people know the next step that's coming. It may be, it might be an email, and then we may follow up with like a bridge call or something and say, okay, hey, let the teams know that they can come on and start to validate these things are working again the way they expect. So our automation cycle looks something like this. This is kind of the words part, and then this is kind of the way that I decided to present it to them, right? Or you guys as we do the course. And important to note, sometimes you want things to always finish. Sometimes you want things to not always finish. This is the determination you're going to have to make. Let's say that I was running something against, 1,000 servers to patch them on a patch weekend or something. And what I might want at the beginning is, my trigger is going to be a manual kickoff in this case, right? And then my input validations would be, whatever checks I have that I've got a good list. The list can be parsed correctly. I've got a proper inventory. Maybe I pulled it out of some CMDB, API for all the systems that are released for us to do our patching this week or whatever. And then we go down to, we don't want to fail there. I mean, we may fail out servers that we can't parse correctly or something like that, but we don't fail the whole automation. The automation still has to finish. What we might do, though, is keep them in a different list, and then that list can be reported out on later. Tends to be what I do is I report things out as I go. I kind of put system and check flags the whole time. And at the end, I report out everything. And then what will happen is, you got a few fails at each step, and then you can go and those are going to be the ones that you're going to remediate manually with your teams or whatever. We'll talk about painting with a wide brush and the Pareto rule here in a little bit. But we get down to system checking, handled by evaluating variables you create with the things that you plan for, and I always talk about painting with a wide brush. I try to get as much into the automation as possible, as much into the time I have and the checks that I can do in a lower environment before we go live to production or something. But the point is, we paint with kind of a wide brush here, because there may be things that get added in that just we're not going to be able to patch, or we're not going to be able to work with, or we're not going to be able to do whatever with. So we just kind of paint with a wide brush there and get what we can. And then I always say separate the systems out into groups. All the Ubuntu 20 boxes, all the Ubuntu 22 and 24.04, of course, but each of those different versions. And then we do a patch or a deployment or a fix or whatever we're doing to those systems. Something that we've tested in a lower environment. Typically, patching has a fair amount of things that we do beforehand in lower environments, and we talk about that in the other security engineering course. Deploying things, we're going to be deploying things in and out of this course a lot, where we're going to overlay some application and then put something on the top of it, that kind of stuff. Or maybe we fix something. We found a deficiency in our system, so we fix it. And then there's also has to be the process in that case to put that running fix back into our build fix, like a build type thing, so that when new servers get deployed, they don't reintroduce that problem again. Because you don't want to be having to go build servers over here, do steps 1, 2, 3, 4, 5 fixes later. That's one, that really bites into Netflix time, and two, it's or messing around time as an engineer, and just causes nightmares in general. And then system validation, right? We check the system is back in working order. At a minimum, I would tell you in system checking, you should make sure the servers are on. I often give this example of, this was early on in my career, I remember this, running a team and having to go patch, 1,000 servers, and then at the end we find 20 of them down, and we're like, wait, were those already down? Shoot, I don't know. Now you've got 3 more hours of fixing those 20 servers, maybe only to go find later that they were turned off by the team. They're like, why are those servers back on? That was a change from 2 weeks ago, and you guys just had them in different decommission states or something, and those weren't even supposed to be on for this. And you're like, oh, if we just checked them at the beginning. So for me, I always check everything at the beginning now. I always know exactly what servers are down at the beginning. So at the end, I can say those servers are still down and I don't care. And if you want me to work on a Monday, we can, but I'm going back to sleep tonight because I'm done with my patching for the weekend, right? Whatever. That's system validation. And then again, report out. Reporting out can just be to you and then you can forward it on, or it can be something that's, open kimono for everybody in the company to see. If you guys have never heard the term open kimono, it just means that like a team is presenting all the evidence and not hiding anything. It refers to holding your kimono open so that they can see that you're not armed, right? You're not a threat. All right. So that's automation cycle. And then, by the way, that's that first question in the week is that. So if you're going to do the discussions and if you're going to follow along with the course, you do have to answer those in the discussions. Nobody has to do anything. I'm not making anybody do anything. But if you want to do the course with us, you do have to answer those questions. Okay. And some people are like, well, I don't want to do stuff. I don't want to be seen. Your work's going to be seen, guys. If you're going to be an engineer, somebody's going to see your work. So pull that Band-Aid off now and just get used to people seeing what you do. All right. So system checking is validating, and I put a little asterisk here, because we can remediate here. We don't just have validation implies that I just look over things and go, well, 9 of the 10 are there. I can't do nothing about that 10th one, so we'll just go on. But it's not true validation, because we will fix things if we need to. So validate that the system's in a good state to move forward. So we might check that the operating systems are what we expect. This patching this weekend I hoped was only going to be rel 8 and 9, but we happen to have like 2 10 boxes in there, and I go, shoot, well, I haven't tested for 10, but DNF or package should still work if we're doing Ansible. We may check that software packages are installed at the expected version. So before I start maybe a new deploy in an environment, some dev team tells me to put a new version of their application out there, and I get, in their little environment file, we must be at least Tomcat version whatever or higher. I might check that the software packages in that environment that was built months ago have that new version of Tomcat. And since I know that that's part of where this end state of this system is, I may in my remediation just do that before I start the normal things, because you say, well, why would you do that? Well, because look, in the dev environment, I was probably standing up brand new servers with brand new stuff, right? And then I was laying their code over it and everything worked fine and we were happy. But if I go just trying to jam their new code into an old environment and I don't validate that the software packages are what are defined and what needed, I'm just causing myself a problem, guys. It's like I'm whacking on the side of a nail instead of straight down on a nail. I'm causing myself my own problems. Why don't I fix the environment? Now look, we're talking about the world as it is, not the perfect world as it should be. Because some people are going to go, well, maybe you should just be running Kubernetes, and maybe you should just deploy a whole new a whole new product, a whole new container, and not even worry about that, Scott. Ha ha ha. And I'd say, well, that's a beautiful, wonderful world you live in, but that's not where all engineers are. Sometimes we're down working on physical servers sometimes. Most of the time we're working in virtual machines, but I don't know where your career is going to take you. And I can just tell you, sometimes you're not going to have the luxury of blowing away a whole system every time. Sometimes you are going to be updating a system in place, and this is a reality, right? Sometimes we're just able to deploy a whole new thing, and this becomes a moot point, and we just go on with our lives. But that's not always true, guys. I would say, in my experience, the number of companies still running stateful servers out there, as opposed to like stateless or like Kubernetes with containers, I'd say it's still probably, in my experience, over half of production workloads. That's not going to be true in somebody who's working with like bleeding edge and like brand new startups and stuff, sure. But I'd say a lot of companies that are pretty risk averse are not on all container systems right now. So anyways, we may check that services are running and or ports are responding. We may, for patching, we might validate that repos are configured. Can I download all the metadata for that repo, or is something blocking me, right? Do we have something that needs to be checked or something that needs to be validated? This is a big one that I used to have. So, oh man, sometimes people will have to carve up servers for CIS benchmarks. And STIGs are the same way as well. But typically with like CIS benchmarks, and back when maybe you were doing like 40 gig virtual, devices for your machines or something, you'd have 40 gigs for the hard drive and you carve them up, but var/var would only get, 4 gigs, let's say. Well, 4 gigs sounds like a lot when you're just talking var, and then var log is off on its own, so that's not even in there. Well, var cache can fill up. You say var cache can get 4 gigs of data. Yeah, var cache can get a lot of data in it, and that's where all of your DNF and YUM metadata goes for Red Hat. So I've actually seen systems that can't download, they can't patch because they can't download and fill var cache anymore. So one of the things we would do is we just go validate and clean out that cache and make sure there was at least 2 gigs in it. 2 gigs is typically enough. I mean, 500 gigs is typically 500 megs is typically enough to download and do all your patching. But 2 gigs was kind of like our standard. We would try to make sure we had, right? And RHEL systems. Look, one of these. This is a big one, like the RPM database. We can just validate that database isn't busted. Sometimes they get out of whack. Sometimes people are messing with them, or somebody's got even just sudo on that system where they can do some basic little configurations and they can change things around. So you just make sure the RPM DB is there, and if you need to, you can fix it. You can just do an RPM database rebuild or whatever it is, and it'll fix it, and that system will then be able to take patches, and you won't have any problems with it that night. So it's kind of like you're smoothing over what's going on, as opposed to just letting the system have problems as you try to patch or do whatever you're doing. And then this is one that I'm big on. We may check that no connections are being made to a system. Maybe you've got a bunch of servers behind like an F5 load balancer or something, and you're going to roll through like 2 at a time. Maybe you got like 10 servers behind an F5 load balancer, and they are production systems, and they are still taking the load. And maybe you've already done one of the servers, because sometimes we'll have done one of the servers and left them in like a 1 box, or what we call a canary type deployment. So now he's been sitting there running, and we know that the code can take the load and that kind of stuff. Maybe we're going to hit the other 9 systems, but we're draining 2 nodes completely out, and then we're doing the work on them, and then we're bringing them back in. We can validate that no connections are being made to the system. And then maybe even after a certain time, we have like a hard cutoff, and then we just kill those systems out and assume that whatever's stale after, 5 minutes or something, whatever your appetite and tolerance for that wait is, right? Because every one of those is going to add for each of those blocks of systems more time to your overall automation, right? And that can happen parallel to other things and that kind of stuff. So the point is, system checking, this is not an exhaustive list. This is just things that I kind of thought of when I was putting this together. So system checking can validate and fix, right? There's a little and fix any systems to be in a good state, so it's all kind of smoothed over so that we can then roll along the automation the rest of the way. Okay? All right. So this is my little Plinko machine. I found the most cursed image I could find for this. System checking is also about grouping servers. You don't know what's going to come out of that box. You don't know what's going to come out when you're going to patch. You don't know when the CMDB team and you work with all these other teams and you ensure that you have the operating system at the level, everything that you expect. Well, you don't know what's going to come out of that gate. People can drop new servers that weren't in the original patch list. So we can group the servers by different things. So maybe RHEL 8, 9, 10, maybe Ubuntu, and then maybe we have an unknown group. Maybe, God forbid, a Windows machine slides in here. We can patch Windows machines if we needed to from Ansible. Typically what I do is I fire off single shot PowerShell commands. Probably more efficient ways to do it than that, but if I'm using a tool already to patch, we could do that. Now, do I want to spend all my time doing that? Probably not, right? Not in that context. There's better tools for that. But what I'm saying is I can still group things unknown, and then when I report out at the end, say, oh, also these other machines existed. And then if somebody says, hey, Scott, we need to get to the bottom of why those 5 machines are unknown, I say, well, that sounds wonderful. That sounds like a problem for Monday morning. That doesn't sound like a problem to troubleshoot late at night when the bulk of the patching work got done. A bigger problem might be why those servers got into these lists and hadn't been checked before that, but that's one of these things that we can take back to the change management teams and stuff later. But it's necessary because, again, you don't control what comes out of the gate. You're just the Linux engineer, or you're the team lead or tech lead for your team, and you don't control what gets released to patch that night. That's a fight for management. I tell my engineers all the time, man, if we have a requirement from security to patch things, but the teams that own them don't give them to us to patch, that's a management problem. I'll let management go fist fight that out because that's not for me to fight. I'm the guy who does the automation that patches the servers when you give them to me. But if you never give me the servers, well, I'm rude. I have the option to just take it. But if I'm going to take downtime on a system, it typically has to be approved or it's going to be my job, right? So this is the kind of thing where I'm telling you, like, you don't have that kind of control. And again, I don't think you should waste time getting gray hairs over it. You get gray hairs over plenty of other things. You don't need to get them over that kind of crap, right? Let the management go fight that stuff out. But that's my Plinko machine. I found the most cursed Plinko horse. All right, so system variance. So then you say, well, what about, there is variance. You've admitted there would be variance, and I say, you're right, I have admitted there will be variance. So how much do you prepare for? Well, it's obviously not feasible that you can predict everything. You can't predict all the servers that somebody might list. They may even give you bad names of servers that don't exist. That's fine. I just take those and they go into my broken server pile immediately, and I report them out at the end, and we go, oh yeah, those are all stupid names that don't fit our naming convention. They were never real servers to begin with. But the point is, we report out, hey, these are the 1,000 servers you gave me. This is the list back at the end. All the ones are done, and all the ones that couldn't be quantified or dealt with in whatever way. So I always tell you guys about the Pareto rule. The Pareto rule is this idea that 80% of your effort is well, let's put it this way. The way I normally think of it is 20% of the inputs are going to cause 80% of your problems. And that's probably true. It's, in fact, the discussion is how much has that proven true to you in life? Like, or do you think the Pareto rule is a good general rule, or have you seen something else? And it's not to argue with people about it. It's just to tell you that generally engineers tend to think 80% of your effort will just result in things working, and then the few systems are going to give you the most problems, right? Or a few users are going to call you the most on the help desk. I was telling my wife about this when we were driving around this weekend up in Montana, and she was like, oh yeah, we have 4,000 new teachers coming each year to the school district, and it's the same 20 calling the help desk. And I'm like, that doesn't surprise me at all. Doesn't surprise me at all. And then I say, suppose you want to paint a large wall. Which one of these are you going to pick? At least to get the bulk of the work done. I'm not talking about trimming in later. But that does bring up an interesting point. Like we talk about, I always call it painting with a wide brush. I want to hit, if I have 1,000 servers going, I would love to see 980 of those servers, which does not perfectly fit with the Pareto rule, I know. But I would like to figure out the use cases of, when we patched last time, 900 of them worked, and then I had 100 as a problem. And of that 100, if we had just done that RPM DB fix, it would have solved 60 of them. If we had checked var cache, it would have solved another 20 of them. And then now we would have had these other ones that they were all kind of these undefined, we couldn't get in, or the host keys were bad, or just all kinds of other things that can happen, weird stuff in a system. But the point is, I got 980 of them out of the way with my automation. And then me and my, I don't know, maybe 5 engineers that'll be on like a patching of that big for the weekend can just knock out those other ones pretty quick, and we could be reporting out to the company within a couple hours. Hey, all of our stuff is patched. Everything's done. Call in the application team. Call in. Get the next part rolling. They can validate. We can further remediate if we need to, but otherwise, we're good for this. So that's how much variance I think you should prepare for. Because again, you can sit around here and noodle on stuff all day, and you will still have some systems that fail, because you can't possibly think of all the things that can fail. All right. So review, we got the automation cycle. How does the automation cycle function in enterprise? Often we want everything to finish and then report out the bad things to us. This is true of a lot of system stuff that we do. We want deployers often to flag and then just give us a report at the end of how it failed if it was going to, so we don't just keep having to run it to see what the next problem is, right? That's a hassle. And then I say, how do we build for all the eventualities of differences in so many systems? We paint with a wide brush. We try to solve the most problems and kind of adhere to that 80-20 rule of, well, I can get most of the things and keep them from happening again. System checking, what do we check? We make sure the systems are all there, right? It's like your own system validation of whatever input you got. And then what do we need to know to differentiate systems? We need to pull variables about the system, either with Ansible or Python or Bash or whatever you're doing. You may find different ways to pull the different information about the system. All right, so if you have questions, message me in Discord about it. Let's pull up let's do a little of the course for this week then, right? This is all coming out still. The guys are still putting together the book, and I still owe them a few things, but there's the worksheet, and the worksheet is kind of the work you would do if you were doing the course with us. You fill it out as you progress. Some people have been putting them up in Markdown when they're done with them in GitHub. I think that looks great. But here's the discussion for this week. Review the automation cycle presented in Unit 2. So there it is right there. And I say, what would you add or take away from this drawing? Was there anything there that you thought could have been worded better, that kind of stuff? It's not to fight. It's to make you guys think about what kind of flow here works for you. This is just the one that I use, right? I mean, I never saw this codified down. In fact, when I was drawing it, I was like, I guess it's good enough. But this is the way that I think about my automations when I build things to work across thousands of systems, right? When might you want something to fail during an automation, and when might you not want it to fail? And that's a valid thing to think about. Do you want, it's some people, there's actually a term that people use in project management called like stage gating. We get to somewhere, and if it doesn't have, if there's not a certain maturity to what we're doing by this point, we fail it. And that's a thing that people do, right? So this is a thing to think about, one discussion question. Your next discussion question is read about the Pareto rule, or the rule of 80-20. It's on Wikipedia. It's all over the place, project management. And I say then, basically, in your own words, what's the general stated rule as you understand it? And then, do you agree with it? Has it been your experience? Can you think of a place where it's proven true, and can you think of a place that it's not proven true? I think there's definitely places where the Pareto rule is not exactly true, right? But it's probably in net effect for people similar to what they've experienced. I think that's why it resonates so much with engineers. People who like solving problems and deal with problems often. I think the Pareto rule, like you're like, man, I keep hitting that. It's that one damn thing again. If I just write the thing down, I'd save myself all this trouble. So here's some definitions and terminology and things that you would fill out and think about, or if you didn't know about them, you would. If you had links or terms or useful tools, you could do that. And then the lab assignment is from our lab book, right? The lab book's going to be published in this page here later. And then the reflection questions are, what questions do you still have about this week? And how are you going to use what you've learned in your current role or in the role that you want to get? Okay? So here's what we're doing for the week then, right? And again, I'm going to get this updated. So I'll link this to you guys that want it. This is where the labs are. Although we also have the labs available in our ProLUG lab environment. And this is the lab that we're doing today for anybody that wants to follow along. I built this the other day and it worked, so it should still be good. And then when we're done with this as a recording, I'll go ahead and stop this and I'll probably pop back on and just work through the normal course, but or work through finishing up the part of the book that I want to update. Get that to the guys, but I'll move this over a little bit so you guys can see it, okay? It says right here, welcome to ProLUG automation. And it says execute bash commands to interact with the OS. So this lab is designed as part of a larger instruction that is free from the professional Linux users group. So that's this that you guys are watching if you're watching this. The lab book for the course can be found here, and this links back to here, but this will eventually get fixed if we change it. You have found yourself in a bash shell. Bash natively interacts with the Linux OS via built-in tools and native tools. So there's some tools that are built in, some that are native. Interact with the OS using bash and scripts provided in /root. So we have the ability, well, when this is done, we're going to have the ability to just check what's going on in a running operating system, right? Check all the values of running processes, and we can count them up. All kinds of other labs will show you all kinds of other interactions, right? This isn't designed to make you guys an expert in any of that stuff. It's to show you how a lot of this stuff feeds back as we keep learning how to do it. So PSEF shows you a bunch of things about the system, and then we can count that up and see, okay, there's 208. And then we go and we run this script, right? So there's a script, u2 script1.sh, and that shows you some things. So it's some script. Looks like it's checking some file, and then it's checking the bottom of the file, right? It tells us some things it's doing. And then we can go look at what that script is doing, and it says, oh, it's doing the simplest thing ever. It's pulling a file and displaying the first 10 lines here, and then it's displaying the last 10 lines. Okay. Not anything super interesting, is it, right? Something most of us learned how to do the first day we ever got into bash. Then maybe we go and we look at this next script. So we got another script to run. And this script created a file in the root home directory at this location. And then it put some contents in that file, and we can go see, we can go look at it here and see there's a log file that was created. It was created right now. And then we can go and we can look inside that script and see what it did, and then how it displayed that file and showed us what the contents of that file were. So just some script, right? Some script that's interacting in some way, in this case, with the file system of the operating system, right? And okay, that's fine. And then I say modify with VI or Vim, and I say you may have to read the field manual to continue, but maybe you go and you VI that file and yeah, could you make it use a different date format? So I have these different date formats that I can use. There's the one that we used there, but maybe I could read the man on date and go down a little bit here and say, okay, could I make that instead of just -F? Could I maybe use, let's use one like this. There is a lowercase s, second since epoch. Right? Does everybody know what epoch is? It says it right there. But I say date plus %s, and that shows me some number, right? And that is the epoch time, right? That's the time that all Unix and Linux systems operate off of on UTC, right? That's the time that's running everywhere, right? And, well, for Linux, right? Linux and Unix style systems. And that refers back to January 1st, midnight of 1970, right? And if you ever get lost or wonder, whoops, if I could spell epoch right. There we go. And there's our epoch time. January 1st at midnight UTC, right? So that's universal. It's not here or there. It's not whatever time zone you're in, or if you don't switch. Like we don't switch time zones in Arizona. Well, most of Arizona, Phoenix for sure does not, but all the rest of the country changes. So it kind of like slides us around because we don't move and everybody else does. But that was the first one. That was just interacting with the operating system a little with Bash. And then we decided to go check out some Python on our system. And I say interact with scripts that are running Python and see if you can modify their various outputs. So we're touching the system and maybe, whoops. For this one, maybe we come in here and we run this script and we say, okay, this script outputs some things. I don't know exactly what it outputs, but I can go here and I can inspect the file and see if I can modify it to show the last 15 lines. So I come down here and I see that I'm using the Python 3 interpreter and I'm opening some file and then I'm reading through it for the first 10 lines and the last 10 lines. And the way we sliced that was right here from the start to the 10th, and then we went backwards 10 positions and went to the start, right? That's kind of how those are read. And could you modify that over here to be 15 lines instead? I think most of you could, right? I'm kind of throwing some softballs here, but could you do that? And then down here, it says that we're only going to show, this one is just reading the last 10, right? So, okay, that's interesting, somewhat. And we go down a little bit, and then maybe we run this other one, and this one does something completely different. It's just showing us some values. So we go and we read that, and we say, okay, this thing's reading that same file, but now it's looking for people that have the bash shell as their shell set at the end of the file, and then it's only printing out the users from the very first field of the file, and it's splitting on colon because it's a colon delimited file, right? So it starts to get a little more complex, but it's still something that I think if you were to like head etc pass wd, I think you could probably go, okay, it's looking for bin bash, and there's the first bin bash, and then it's going to look over here based on the field delimiter for the first line. So root, there's the first column, root, boom. Ubuntu is probably the next one, and we could go and we could find Ubuntu, and we could even grep bin bash. We could do it like that, I guess. Probably cleaner like this from etc. Right, something like that. And then I would see, oh, that is the same output that I'm seeing from when I executed the file there. But again, it's stripping and only showing the first. Yep, there we go. Boom. All right, so we kind of validated that our tool is working the way that we expected, which, by the way, is also a useful thing to kind of practice and understand. And we say, okay, that's cool, but now we want to use some Ansible, right? And Ansible is going to behave a different way because we're not running it exactly like a script. It's kind of happening a little differently. So we're going to go run this playbook here. And the playbook is going to run against localhost, which is just a local machine. And it's going to go do something. Well, let's go see what it was trying to do. It says it's generating some scripts. So this thing is making scripts for us. That's interesting. Let's go look at how that might look, because it may be useful for you to generate a file on the fly based on variables. What I'm going to show you here in a second, what's about to pop up here, is the dirty way to do. Again, I don't think there's anything wrong with quick and dirty, guys. If it works, it works. But this is not maybe the cleanest way. Most of us would use a Jinja template, but sometimes you just need to get a bunch of files to a machine. This is a way to do it. You can actually generate a file with the copy command. A lot of people don't use it this way, but this is very possible. We generated this file, and here's the content. Everything underneath here is generated content that goes into that file. So we just generated these U2 generated scripts, generated script 1 and generated script 2, to do the same things that the bash scripts originally done. So we just generated bash scripts from Ansible. Would you normally do that? Probably not. But this is a useful thing to understand, that we can interact with the OS in different ways. Plus, if you're not familiar with YAML and an Ansible playbook, you get to see a little bit of the header. We have a whole course on Ansible that's in Killer Coda that'll get you building those. But I think seeing it often as an engineer will help you kind of understand. And we're going to deal with inventories this week coming up. So that's all good. But this thing did all the things it needed to. It generated them in an executable fashion. So now I could actually look in here, ls-l, and I can see those two generated scripts. And I should see the contents exactly like this of those scripts, right? So if I cat u2 generated, oh, I can't believe I did one with a lowercase, or one with an underscore and one without it, right? But now we look there, and then we look there, and we've got what we need. Okay, so now let's look at executing. We're going to actually use Ansible to execute those. Can you use Ansible to execute a script on a box? Absolutely you can. The reason a lot of people don't like that is because it's not technically idempotent anymore. It's now you're firing off a script and Ansible loses control until the return code happens. And Ansible can't tell you how successful that was except by the return code you give it. CloudFormation to make passing a script in a somewhat reasonable way. Sending, I'm not actually sure if it can do a base 64 or not. What I can tell you for certain is if I want to do anything complex, I'm going to do it in a Jinja template. The reason I kind of call this quick and dirty is you can generate one of these quickly, but I would not use this for anything but like the simplest generation of like a file, or like maybe you needed to push over real quick like ntp.conf or something, and you were going to drop it in like etsy ntpd.conf or something, like you just needed to get something out there. I might use that. But honestly, like if I need the control of the placement of everything, I would almost 100% of the time use Jinja 2. In fact, I can tell you professionally, I've never used this. I've never used this professionally. I've used this a few times when a few years back, me and Michael Pessa were doing some stuff, and we were generating fixes for something. I think actually we might have been using, it's like a Prometheus deployer that I was doing. But then all other times that I've done it, and specifically I was deploying Prometheus scrape configs into a Prometheus node from our jump box. Other than that, I almost always use a Jinja template. So remember I was saying earlier about like quick and dirty is just being able to do things quick and dirty is very powerful as an engineer. That being said, this would stay in the quick and dirty pile, and I would only use this like if I just needed to produce something quick. If I'm actually going to produce it and make it like a work artifact, it'll always be a Jinja template for me. I'm not telling you guys to do it that way, though, because if this works and it's a good workflow and that's relatively reasonably readable, I think it's fine to do it that way, right? But let's run this. So now we're going to run those generated scripts from Ansible. Also, again, another thing we wouldn't necessarily do with Ansible, but let's go run it, right? And it's going to go and it's going to deploy and it's going to run. And then it actually gave us some output back because the output was captured. Let's look at it real quick. When we went and ran it, so we went and ran the script with the command. You could also use shell and you can also use exec there, and they behave differently. Command works fine for me most of the time. We register all the variable back, and then we went here and we looked at just the standard out from that variable. I'm going to change this here in a second, and we're going to look at it as the full variable that was captured, everything Ansible can know. But then we also ran the other one. And again, I don't know why I have an underscore here and not an underscore there. That's an oversight on my part, but it's not that big of a deal. Let's go VI this file real quick and let me show you guys this, because I think this will help to just see, like, this is why I think Ansible's so powerful, guys. I tell you guys sometimes that Ansible's super powerful in this one way right here. Well, it's powerful in a lot of ways, but let's go $, and then we should be able to do dot escape : WQ. And then let's rerun that playbook real quick. Right, all I did was remove the .standard out, because now it's going to display the whole variable that was captured when it ran that playbook. So watch this real quick. This is going to be a lot more output, but it's going to show you all the things Ansible knows about that script. So before we were getting just the script1 underscore output .standard out. That's all we saw earlier. Look at all these other things Ansible knows. Maybe we just need to see the delta to know if anything took longer than a second to run. That might be important to know. Probably not. We always want the return code. This is only green because that return code is good. If it wasn't return code good, this would be a different color. There's an interesting thing to understand right here, changed true. Ansible, when it, again, I said when you run a script from Ansible, it's almost like a captain on the deck of a pirate ship putting a little flame down and firing a cannon off into the night, when Ansible controls the modular run of something, when Ansible controls it from start to finish, it can tell if something had to change or not. It cannot do that when you use a command or a shell or an exec, one of those three modules. So changed will always be true, because Ansible's like, I changed something, I ran a play, I ran a script, and people get really hung up on this. Like you'll see people like fist fight in like Ansible and automation forums about you can never ever in a million years ever use a script, because it'll always come back failed. You can't be idempotent. If you understand, I'm using this to gather information and report, I don't see the problem, because you don't care about the output value of this. But to be fair, if there was like a handler that was applied to this, the handler will always trigger because the change will always be true, and that is not good idempotency. Like we restart every time I run a playbook, I restart Apache, even though Apache didn't have any configuration changes. But I ran a script, and the script always said true, so it always ran the handler and restart Apache. That's sloppy work, right? We don't want to just be restarting Apache willy-nilly in a system. That's really bad in a production system. So we don't mess around like that. All right. So, anyways, I say go modify it. Can you do some other stuff? What if you ls in this directory? Do you see the newly generated scripts, and are they the right permission sets of 755 like we set? Yes, they are. So there we go. And we get to the end, it says, look at you learning automation. You interacted with the operating system using your different automation tools. So you touched a bunch of things. Again, this course is not designed to make you, we're not making you an expert in Bash or Ansible or Python. There's a million other places that are better at this. This course is really to focus on Ansible, but I kind of want to show you guys that there's these other tools that exist that do similar things, but there's varying degrees of effectiveness as we get into some of these more specific use cases. And, I'm not trying to make you guys, part of the cult of Ansible, right? But if you look at it and you go, man, this is a pretty good tool, some of you might join the cult of Ansible, because the water's pretty warm, right? It's pretty good little tool for most of the things we want. All right. So if anybody's looking to engage in the course, all you got to do is join our Discord. It looks like this for Discord. Over on the Twitch side and over on the YouTube side, here's the link. All the course is free. All you guys got to do is come out and hang out with us and work on the stuff. And then we do have a cool little certificate that you get at the end if you complete it. But it is a lot of work. It's going to be 16 weeks, and there's a lot of stuff to do. And the guys are still building the book out. So the book currently kind of looks like this. And then you can see the different pieces of it as they're putting the different parts of it together. So, all right. Questions, just message me on Discord, or, feel free to drop a comment on the YouTube side or whatever. All right. I'm going to call this here and say that this is the end of Unit 2, and we will get into Unit 3 is this Saturday. So I will see you guys then.